We've now moved into Calibration 9, aligning the SQUID sensor to the SQUID window Z height. For this calibration, we're going to run a magnetic-only scan, with no optical data. You'll find the scan requirements in the info box at the lower left of the interface. It's a line scan with a step size of 10 microns in X and 50 microns in Y, a 200 micron distance from the sensor to the sample, and a current of 1 milliampere AC. After reviewing the scan parameters, we close the setup box and head into the acquisition wizard. Here, we start by changing the scan type to magnetic. On the far right, where it says XY typical, we switch that to line scan. Next, we begin preparing the leveling. We click on Touch Probe Assisted Leveling and then lower the probe using the partial Z lower option. Once the touch probe is lowered, we turn on the joystick, set the speed to fast, and select 3 leveling points in a triangular pattern. These points must be chosen within the area we'll scan later. In this example, we're scanning along line 12, so the triangle is placed in the region around line 9 to stay within bounds. Once the 3 points are selected, we use the automatic leveling function and wait for it to finish. When leveling is complete, we close the tab and move forward. Now it's time to define the scan area. We open Step 5, Set up Scan Area, and click Initialize Scan Area. Make sure High Residential Camera is selected and that camera is selected in Scan Area Translation. Once verified, click Move to Location and let the stage reposition. With joystick control enabled and the speed still set to fast, we locate line 12 on the sample. We position the crosshair in the center of the line, then move 400 microns to the right and mark the endpoint. Then we go 800 microns to the left and mark the start point. Since this is a line scan, the Y position isn't relevant. Once the start and end points are set, we hit Done. We now confirm the distance below the window is set to 200 microns, as required. With position complete, we perform a pre-scan under the touch probe using the Dino Light camera to visually confirm there's no contact with the sample. If everything looks clear, we continue to Step 7 so that before starting the scan, we adjust the X step size to 10 microns and ensure the Y line count is set to 50. Next, we move into Advanced Current Control and run an 4-curve test. Then click Start Curve Generation. This verifies the correct line is powered. In our case, we're scanning line 12, but we power both line 12 and line 9 using the test board. Once the 4 test passes, we set the max voltage to 5 volts and max current to 1000 A, then confirm with voltage and current control. Once it's complete, press Done. Now we're moving to Step 9, ready to scan. We name the scan file, select where to save it, and click Start Scan. It's a good idea to keep the Dino Light camera active during the scan, so you can monitor the probe in real time. Once the scan finishes, we click Done and head to System Calibrations, opening the tab for Calibration 9. We click on Load Magnetic Field Scan, and from the files, we select the X-direction scan file only. After loading the scan, we check the Z distance box. It's located in the middle right of the screen. The value here must be 200 microns or less to pass the calibration. If the value exceeds 200, say 201, that means the SQUID window is too far, and a manual adjustment will be needed. In that case, we stop here and contact the team. If the Z distance is within spec, we click Save Calibration, and just like that, Calibration 9 is complete.